All right, let's get this project wrapped up. Ready for the home stretch. Hopefully you are somewhat familiar with this look right here on the screen. You've got your classes figured out, got the frequency in each class. Remember, you needed to make your class size a little bit bigger than this calculated width so that everything fit in that, especially in that last class. So since the maximum was 6.75, this one we went up a little bit more than 0.73, got all 40 of them in here, created this histogram with the classes. Yours can look a little different. If you want, you can always double click on those and change the width, change the gap width if you want. I like to get it to look like a histogram with not much space between the bars. You can fix that, make it look different. Gave it a title for run times. See over here in the instructions, it just says for the times for the marathon run, create a frequency distribution with 5 classes, 1, 2, 3, 4, 5. Got that. Use a chart function, create a frequency histogram. That's that. We are good to go. Got 4 questions for you guys, and those 4 questions, go ahead and answer those right in the Excel spreadsheet. You're going to open up a cell. Like each one of these cells is by itself pretty small, but what you can do is you can say, you know what, let's grab all of those, come up here and merge all of those cells together. That's what I did here. And then after you finish entering in your response, your cell's going to be too small. It's going to look like this. So you're going to have to drag that down so that your full response fits in the cell. And then you can go down here and answer question 2 and type all that in. And as you're typing, you'll see that it won't all fit. And then span the row. If I hit return, it's not all there. And so if I drag this down, there you go. I wrapped the text, merged it, everything fits. So there you go. Answer your 4 questions. The 4 questions are: which quantitative category has the highest variability? You can go up here to your coefficient of variance and answer that. Which quantitative category has the lowest variability? And then give the minimum and maximum times for the longest quartile in each of the 3 events. So in the bike, the run, the swim, the bike, and the run, you're going to give me the minimum amount of time and the maximum amount of time required in the longest quartile. Okay? There's going to be some quarters of your data where a quarter of the athletes are coming in real close together. There's also going to be other quartile of your data where the athletes are a little more spread out. So give the minimum and maximum times for the shortest quartile in each of the 3 events. This is the quartile in each category where the times are closest or compact. Okay? So in each of the events, swim, bike, run, finish, given the start and finish time of the longest and shortest here in 3 and 4. Okay? And you can go ahead and organize that in a nice, neat way trust you guys to give me a good looking answer with 3 and 4. I'll let you be creative on that one. But what I really wanted to do is, one, give you a look at what phase 1's going to look like when it's all finished. You're going to have all of this area down here filled in with answers to these 4 questions, and then you'll be ready to move on to phase 2. And phase 2 is all about confidence intervals and what the necessary sample size would be for a particular margin of error. Okay, so we've talked about the issue of some names in other countries being a little different than what we're used to here in the United States. And I think I made things a little too complicated. I think you guys will probably do a really good job of figuring out which of your 40 athletes are females. So for this one, it says, based on the proportion of female athletes in your sample, calculate the 90% confidence interval for the population proportion of Ironman athletes that are females. Okay, I am quite confident, can go through here and go Marion from, that's a guy, Jan, it's a girl. Okay, so you can go through here and you can say, all right, we're gonna highlight the ladies. Maddie, I'm thinking that's a lady. Lynn, you can do this. Just go through and highlight. Oh shoot, if you click on their name, it'll take you to the website. Luca, and let's see, Les, Samantha. Go through and figure out how many of yours. The best job that you can do at picking out, I'm guessing this is a female. Here you got another female. You guys can go through and, without making it too complicated, you can figure out the number of females in your sample. Now, I just, in getting ready for this video, I created all of these parts right here. So I'm setting this up here for you as an example of how you can organize the 4 parts of phase 2. Okay, so here's how I would go about doing it for the most number of points. To create the 90% confidence interval for the proportion of females in the population, you're going to have to know the number of females in your sample, what that proportion is out of 40. Grab the z-score for the 90% confidence interval, and then you can calculate your margin of error and the lower and upper limits of your confidence interval, and then give me a nice concluding statement at the end of that. Now, if you're trying to remember, what in the world, that was so long ago, I do not remember. Well, go back to 7.2. Go back to PowerPoint 7.2. You will see there that you have everything you need for calculating the confidence intervals, for calculating the margin of error, and also down here at the end you also have, hold on, give me a second, boom, you also have an example of how to figure out the necessary sample size for a particular margin of error, and we'll use our P's and Q's from our sample as an estimate. So you don't need to use this, you can use this. Alright, then remember to round up to the next whole number. So that's 7.2. This is the 7.2 is the PowerPoint for working with sample proportions to calculate confidence intervals and sample size. Okay. Also, when you get into the next part of phase 2 where it says based on your sample mean, and let's set gender aside for now, calculate the 95% confidence interval for the population mean time to finish each of the 3 events. Okay, swim, bike, and run. So you're going to need to calculate the mean time, the t for the confidence interval. Your sample size is 40, so t is going to be you're going to need to grab degrees of freedom on that. Calculate the margin of error. That is all coming out of section 7.3. So grab the PowerPoint for 7.3 and you'll be able to figure all that out. This is all there for you when you are asked to calculate the sample size necessary for the 90% confidence, to create a 90% confidence interval with most 10% margin of error, blah blah blah. You can go back to, again, 7.2, and then the sample mean, this is 7.3. Okay, that is all there in the PowerPoint. Set up your file like this. You're going to have your numbers and your calculations, and then your final concluding statement, similar to the ones we had in the PowerPoint. And then same thing for calculating the 95% confidence interval for the swim, bike, and the run. And then down at the end where it says calculate the sample size necessary for the females and the sample size necessary to calculate the 95% confidence interval with a 3% margin of error. You can do that down here. Okay? I think you guys have got this. We have the PowerPoints to step you through all of this. The one thing you need to do to get started on phase 3, like I said, go through your PowerPoint, your list of 40 athletes, and as a group figure out who are the ladies. I'm thinking that's a lady. No idea. So Birgit, sure, we'll go with lady on that one. And oh, not really sure. Iris, I'm gonna go with a lady. So you guys decide as best you can who the ladies are, and then you'll be able to answer this question here with help from the PowerPoint, and you'll be able to answer this question here with help from the PowerPoint. Okay, so pull up 7.2 and 7.3 and rock and roll. You should be able to finish up phase 2. Make it look nice, make it easy for me to find everything, label it so that it's easy to read. It's easier to get a good grade when the person grading your work is happy. And one way to keep me happy is to make it easy for me to find the information I'm looking for, and also to use nice complete sentences when you're writing these concluding statements for each one of these parts right here. Okay, you guys got this. Enjoy, and make sure you work together on it, and we'll see you next Tuesday evening when you hand it in. Alrighty? Okay, talk to me if you have any questions.